Hello, everyone, and welcome to our webinar. Today, we're going to be talking about intelligent automation for point of sale systems. We have two excellent speakers for you. Matt McConnell is an account executive here at Eggplant and manages a number of our retail customers. So he's very familiar with the true challenges that retail companies face, whether they are trying to implement omni-channel solutions or simply trying to automate testing across point of sale. Following Matt's discussion, Nick Castleborn will be showing a demonstration of Eggplant AI and how to build out an AI model of your point of sale system. And now, over to Matt.
Thank you, Lexi, and hello, everyone. Thank you for joining our webinar on intelligent automation for point of sale system. I'm Matt McConnell, an account executive here at Eggplant in our retail sector, and I work with our retail customers on our customer experience platform, which includes the test automation of many things across a retail enterprise, including point of sale systems. Also joining me will be Nick, who's going to provide a demonstration of the point of sale test automation. But I'll first provide an overview of the topic and some of the challenges and solutions around point of sale test automation. What matters in retail? Many of our retail customers are highly focused on customer experience, and they put the experience of the customer at the center of everything they do, obviously with an eye toward retaining those customers and maximizing their conversion to purchase. The velocity within retail is increasing dramatically, the velocity and the pace of change, and the productivity of testing teams to try to keep up with those increased velocities and complexities, with always a view on reduction and containment of costs. But the point of sale environment is critical to that customer experience and what we refer to as omni-channel customer experience, which includes the point of sale, but also other ways of interacting with the customers, such as e-commerce, loyalty programs, delivery, and things of that nature. So those retail point of sale systems are increasing in complexity, as I discussed, with many other integrations between systems and devices, such as payment systems and the proliferation of all types of payment options that customers have today, including credit, debit, loyalty programs, rewards programs, mobile phone payments, and things of that nature. The complexity and the integration between point of sale and e-commerce systems, like mobile ordering and mobile delivery. You can order online and deliver to a store. You can order at a store and deliver to home. And all of these systems need to work in conjunction with each other and seamlessly for a good customer experience. Putting an emphasis on newer technologies like augmented reality, shopping assisted applications only increases that complexity and needs to integrate again with the payment system at the point of sale. And then integration to many back-end systems like financial and inventory systems in the quick service arena and restaurant arena, kitchen systems. So the complexity of point of sale integrated in and working in conjunction with all of these different systems creates a real challenge for development, of course, quality engineering teams as well. The complexity in the environments, as I mentioned, not a standalone environment. The systems, including the point of sale terminals themselves, mobile point of sale, mobile devices, mobile associate devices. There's self-serve kiosks in most retail environments. The notion, as I mentioned, of click to bricks, or it could be brick and mortar to online. The payment options proliferating, and the number of different peripheral devices. Things like device automation of what you see here, which is a pin pad and signature capture with a chip reader automated as part of a test automation system. But the other devices, barcode scanning, signature capture, scales, self-checkout systems, and self-service kiosks in the point of sale. All these and being able to test these provides an end-to-end customer experience. A lot of challenges in test automation that we see. This recent survey shows that keeping up with the increasing velocity of agile and DevOps CI/CD methodologies is a real challenge for our retail customers. We have customers that have gone from twice a year releases to monthly releases to weekly releases of point of sale software. And that's a challenge for the test automation and testing teams to keep up with that kind of pace and velocity. The ability to predict the impact of changes in the applications and understand the relationship between introducing changes and the quality of those releases. Meeting end users' expectations is very much a challenge. While teams feel like they are completing their test tasks in many cases, they don't feel like they're actually meeting the end user's expectations and the true customer experience. Finding the technical skills and combined with the domain knowledge of the application is really a challenge. There are many users that have good domain knowledge but are not necessarily programmers or test automation engineers, or you have test automation engineers that don't have detailed domain knowledge. So there's a gap there in finding those resources. Many parts of these applications, customers are finding that it's difficult to automate. The peripheral devices, the end-to-end processes, or traditional testing tools struggle to automate a large amount of that end-to-end process. And then the visibility into the quality information and the status and the results of that testing and how it relates to the DevOps process is a real challenge. So how do you address these challenges? Some of the best practices that we see are testing cross-platform, the omni-channel test automation, so you can get that true end-to-end customer experience that could relate to a mobile order, pick up in a store to a point of sale. It could be a online order and return to store, things of that nature. So being able to test across those platforms and those systems. A model-based testing approach, which, as opposed to a traditional scripting approach, which is expensive and slow and resource intensive, a model-based testing can truly accelerate test automation. Testing through the eyes of the customer and the experience of the customer rather than testing at, say, a code level. And combining that productivity gap of the challenges we mentioned with keeping up with CI/CD processes, with finding the right resources that have domain knowledge but can also create test automation capabilities. Leveraging the analytics, predictive analytics, be able to sift through all of this data that the test automation environment can create to give some predictive information and analytics information for decision-making processes and communicating back to the development environment. And integrating with that development environment, the agile and CI/CD processes and the DevOps methodologies. All the while maintaining that focus on the end-to-end user experience. So for cross-platform test automation, as we mentioned, point of sale is not a standalone application now. It needs to communicate and integrate with a number of different devices and application platforms, including mobile point of sale and self-service checkout and self-service kiosks. Mobile devices, such as store associate devices or customer devices, e-commerce applications for order online, deliver to store, order at store, deliver to home, and ordering from home but return products to store, for example. So the integration into these disparate e-commerce applications with the point of sale. Delivery applications, very common in quick service restaurants where you might order online and then have the delivery mechanisms. And integration into backend systems like warehouse management, inventory control, fulfillment systems. We see many of these point of sale applications being tested, and you go back and verify against backend systems, all as part of one automation flow. To use this cross-platform capability, we leverage a universal fusion engine, which allows you to test against any type of mobile device, tablets, phones, store-level mobile devices, web applications, server-based application, client-server applications. Also do API testing. So there are applications where you may not have a user interface to test against, but you need to test at the API level. And object-based testing. So to test things at an object level. And there are many times that a image-based testing approach gives you the best guarantee of the actual user experience, but there are times when an object-based testing is preferable or more efficient. And then closed-end systems and voice-activated systems, other types of environments. So a universal engine that can address automation across all those types of platforms. And by using a model-based approach, which we'll talk about in a little bit more detail, that leverages a universal functional fusion engine, you're able to separate what you want to test with how you actually test and drive the systems under test. Here's an example of one of the things that we're doing along the lines of easing the creation of the test automation for people like domain experts that aren't necessarily automation engineers. So we're building technology that allows you to point the application at a screen or a portion of the screen and capture those assets and automatically create what we call snippets of automation code that are reusable by either a script-based or a model-based testing approach. So again, pointing at the application, bringing those assets over and automatically creating them and inserting them into a model-based testing environment. So we talked a little bit about a model-based testing approach, and what is that? It's a way of accelerating development and test automation and minimizing things like the time and cost to develop it, minimizing the maintenance of it, and dramatically increasing the test coverage against those applications. Essentially, you create a digital twin of the application or applications and the workflow with all of the options that exist within that workflow. And then the AI algorithms will drive the automation and automatically create the end-to-end test cases on the fly and execute it using that universal fusion engine against the systems under test. And this enables you to focus on the user journeys that are possible, the user journeys that are most common, and leverage that instead of really testing to a test case that you've developed. Here's an example of a model-based testing approach against a point-of-sale system. And in a model-based testing approach, you define states, which are many times screens, but states could be a process flow or something like prepare the systems under test for the test. But in a state, you also have actions, and those actions are the little gray circles and squares that are things you can do within that state, for example, a screen. So it could be an action like proceed to checkout. And from proceed to checkout action, where can you go from there? You can also put in universal actions that could happen at any time. I could exit back to the home screen at any time. For example, on a mobile application, I could rotate my screen at any time. So universal actions can also be put into a model. And for each action in the model, a snippet or a small piece of automation code, very simplified, gets put into the model. And then when you execute the test automation, it assembles the automation code for each action that it proceeds down the user journey and executes that against the system under test on the fly, collects the pass-fail information for that test, and brings it back into the model-based testing system. And then another user journey gets tested. So how does it decide which paths to take? There's a number of different ways to do that. One is traditional regression testing, where you specify a number of particular user journeys that you want to test as part of a set of regression tests, for example. But in this model-based testing approach, you can create a regression test simply by clicking on the path through the model. So you can specify a series of tests quickly and easily by a non-technical user who understands the application flow, but not necessarily how to build test automation, and create powerful regression tests. The other way that the model-based testing works is that it leverages artificial intelligence and machine learning technologies to optimize what you're testing for things like coverage. So the AI algorithms can look at, say, after the set of regression tests are done, what do we want to optimize on now? And this could be maximizing coverage against the model. So it knows what areas of the user journeys have already been explored and can then focus on maximizing coverage in areas that haven't been hit yet. You can have the AI algorithms tuned to focus on important user journeys that you specify, or common user journeys that come over from our user monitoring insights, to focus on the journeys that real users are actually doing in the production software. You can weight certain journeys more heavily than others. For example, in many of our restaurant customers, you might want to weight delivery options because that's 80% of the business, as compared to less weight toward dine-in or takeout options. And then bug hunting is a powerful capability that once enough testing has taken place in a run, bug hunting basically says where we've seen defects, let's test in and around those user journeys to try to isolate some root cause effects. So for example, when I transition from this state to that state, and these three things are true, I'm catching an error. But if those three things are not true, it doesn't produce an error. And that kind of information is very valuable to give back to a development organization to again, help to isolate the cause of bugs in the system. So over and above just saying we've encountered an error, we've tested in and around that, look for other combinations with the AI algorithms to try to isolate the causal factors. So this type of model-based testing approach, as I said, really accelerates automation. You're writing once in the model and can run many thousands of particular user journeys through that model. So for a similar effort of creating an initial set of automation cases, you literally are creating thousands to millions of potential test cases from that same level of effort. And where a traditional script-based testing approach is a very linear line between how much time it takes to create a test case and then add another one and add another one, versus building a model, you have through that initial effort a very much higher level of test automation. So it's lowering the cost of developing the automation. At the same time, it's lowering your maintenance costs, because if you have a change to a screen or an application flow, you're changing place in the model rather than potentially across hundreds of test scripts that you have to analyze what could potentially be affected by this change. So automating that test creation through a model-based approach and optimizing the user journeys through your AI algorithms and directed testing combination. We talked about testing through the eyes of the user, so focusing on the user experience and the end-to-end journey across the applications that they might use. Prioritizing those tests with input from production systems on the real user journeys that are actually happening in software. And then understanding how performance can be affecting the user conversions as well. And that helps you focus your development and your infrastructure investments of the in-store systems based on those factors. We also want to leverage analytics capabilities. So increase the speed at which you can interpret the test results. Test automation creates a lot of input, and usually it can take days to manually sift through that, triage the results, and figure out which ones are really due toward defects in the software, what are due toward automation failures or other factors. So the ability to increase the speed at which you can analyze the results, and then add predictive capabilities. Predictions, things like release readiness, bug content predictions, based on previous test results and based on information from the development environment. And this is going to result in a better understanding of the applications, both at production and development. So before and during and after you go live. So a little bit more detail on release analytics. Again, predictive information like how ready for release is this product based on factors like bug content, quality predictions, performance predictions, and user experience predictions. And how do we prioritize the test automation with the AI algorithms given this information on changes in the software, new features, check-ins, changes in code types, code quality, things as detailed as this type of user, this type of developer has checked in code based on previous experience. We know that that area of code check-in and that particular developer combination has a higher frequency of bug content. We might want to test that in more detail. These provide an overall ranking of the release readiness. Again, taking the test automation data, historical data, and information from the development environment. So to be able to accomplish this, we really need to have good integration with the agile methodologies and environment, CI/CD environments, the DevOps environments that people are implementing. So you want to accelerate the automation to meet the velocity that agile and CI/CD methodologies are driving. And open APIs give the ability to integrate with those environments, whichever of the methodologies that your company may be employing. Most of our customers in retail are somewhere along the journey of agile and CI/CD capabilities, and then bringing in the operation side of it as well for true DevOps methodology. But if you don't have these kind of methodologies in place, or you don't have a test automation framework and infrastructure in base, a model-based testing approach can operate in a standalone and provide you a good background and basis for test automation and results interpretation. So this is all part of our digital automation intelligence capabilities, which includes the model-based testing and the AI optimization algorithms to drive auto generation of test scripts, regression testing, exploratory testing, and coverage maximization. Those drive the Fusion engine that can perform functional testing, performance testing, and UX testing across any device, any platform, any application type, back office systems, even things like mainframes, and integrates into the environments that are common in CI/CD capabilities, HPALM, Jenkins, Jira, many of these systems we are integrating with, and then the analytics capabilities to help optimize the results analysis and the communication back to DevOps. On the operation side of it, we have our customer experience insights platform that gives you real customer insights, tracking of what actual customers are doing in the applications, and the monitoring insights to monitor the health of those applications and alert-based notification of anything that's fallen outside the expected or acceptable ranges. And then that real customer insights can go back and be a feedback into the model-based testing environment to optimize the user journeys that are actually happening in production in the real world, to again focus on the real user journeys and test against the most common journeys as you optimize the test automation. And the combination of that digital automation and the customer insights is what we call customer experience optimization. Be very happy to talk to you more about this platform and answer any questions you may have. Some of the retail customers we're working with on the screen here, we're working across department stores, specialty retailers, grocery and food retailers, and quick service restaurants. So a lot of good experience across a number of retail environments and point of sale environments. With that, I want to turn it over to Nick Castlebar to provide a demonstration of the point of sale test automation, leveraging our customer experience optimization platform.
Hello everyone, and welcome again to our webinar on point of sale testing and automation. This is Nick, and I'm a technical consultant with Eggplant. To keep the show moving along today, I've just kicked off test execution, so if you can see my screen, you should now see Eggplant running. And before we dig into the specific of what's going on here, I'll review some basic points, and I'll begin with a quick overview of the various windows that you see in the presentation screen right now. On the left-hand side of the screen is the interface for Eggplant AI, and more precisely, in this case, we have a model of a point of sale system that we're automating. On the right-hand side of the screen is a view of that point of sale system, and this is a system that we have deployed in our Boulder, Colorado engineering facility. On the bottom of the screen are the consoles, which are exposing various details about test steps and test results as they occur. So that's the basic lay of the land. We have our model on the left, which is executing and driving a test against the point of sale terminal, which is on the right. And then you can see some helpful information at the bottom of the screen about what pieces of the picture we're calling, what different test steps include, and whether a failure or success occurs when a test is ending. So for the specifics now. Well, the first point I'd really like to emphasize and make sure everyone leaves with a good understanding of today is really all around the purpose of Eggplant AI. And in a word, we can say the purpose of Eggplant AI is to automatically generate test cases and also to optimize test execution by finding defects and maximizing coverage of user journeys. So a reasonable question to begin with really is, how is Eggplant doing those things? How is Eggplant automatically generating test cases and also optimizing test execution? Let's start with the generation of test cases. So the model that you see on the left represents possible user journeys that are available to someone who's actually manipulating the point of sale system. In this case, the model represents a number of end-to-end journeys, and if you look closely at the model, you can see that all of those journeys begin with logging in at the home screen, and they end with logging out of the system. So that means that every time we run this model in Eggplant, we'll start by logging in, and if we don't encounter any errors along the way, we'll end the test by logging out. Eggplant automatically generates test cases by navigating different paths or flows through the model, beginning with the login and ending with the logout. So as you see the model highlighting on the left, what you're really getting is a visual depiction of AI-generated test cases. And if you've worked in point of sale before, then I imagine that these flows will seem really familiar to you. Roughly, these are all checkout transactions that include a variable number of food and beverage products. And as I'm sure you've also seen, some of these transactions are further modified by increasing the quantity of some of the items in the cart. So that's really the story, the quick story around automatic generation of test cases. Eggplant is given a model, and then it uses that model with its AI and machine learning algorithms, traversing the model in different ways, and that navigation of the model is synonymous with an actual test case being generated. So to the next part of the question, how is it that Eggplant is optimizing test execution? Well, there are a few different parts to this optimization. So Eggplant optimizes test execution by maximizing test coverage, by hunting for bugs, and by using valuable inputs from testers. And again, how is that happening? So let's talk about coverage first. As each test is executing, Eggplant's storing information about that test in its database. The coverage information that Eggplant's logging is about where it's been in the model and how it got there. So about the different paths. When Eggplant determines what the next test should be, or what the next path should be, it's taking into account where it's already been before and where it needs to go in order to maximize coverage for you. So that's the first part. Optimization occurs because the paths that are generated, the tests that are generated, all when they're put together are maximizing coverage. The next point about optimization is about bug hunting. Eggplant hunts for bugs by remembering where failures have occurred and then by attempting to recreate those errors in later runs. And this is done in several ways, but roughly speaking, Eggplant's doing two main things here. It's attempting to recreate the error as it first occurred along that very same error path. And then it's also attempting to recreate the error in different ways by navigating paths that are similar but not exactly the same as that initial error path. So that's the second point about optimization. We have test coverage, we have bug hunting, and then we also have input from testers. And Eggplant takes into account input from testers in several ways, so I'll just mention two of them here. First is really the model itself. Eggplant's using its AI and machine learning algorithms with the model to generate test cases, as we just heard. And those models are composed of states and actions. States generally represent the screens within a software application, such as the home screen on our model, or the dashboard, or the food menu, or the payment screen. And then the actions in those states, which are the smaller gray boxes in the state in the model, those actions are the things that a user could do within that application screen. Including, in fact, the different actions that a user would take to move in between the different screens. The movement in between the screens is generally represented in the model by those red lines that connect up different states in the model. So that's really one of the main ways that testers are inputting information into Eggplant, is influencing the tests by building this model and by determining what model represents the system. So the second way that Eggplant's taking input from users is what we call directed tests. These directed tests are specific, important flows through the model that testers can prioritize. We'll discuss these a bit later on in the demo, so for now we'll just leave it at testers can emphasize which paths they see their users taking, which paths are part of the core tests that they've already been running, and which paths they see as critical to the operation of this application or system that we're testing. That's really the story about optimization in a nutshell as well. So remember, we're optimizing test coverage because we're influenced by coverage, we're influenced by bug hunting, and we're influenced by those insights and inputs from end users who are using Eggplant. If you've worked in point of sale before, then a good exercise is really just to compare some automated regression test set that you've worked on. Compare that to what you're seeing now. Manually accomplishing all of those items I just covered, right? Maximizing test coverage, dynamically hunting for bugs, using inputs and insights from testers. Covering all of those things is a hugely cumbersome task. But with Eggplant, you get all of that done for you automatically and intelligently. So during runtime, you can see the model executing. The currently running portion of the model is highlighted, and you see the impact that that has on the system under test. In this demonstration on the point of sale terminal, we can see that Eggplant is looking at and analyzing the screen exactly as a real user would. Each time you see a colorized rectangle light up on the point of sale screen, that's an indication from Eggplant that a particular image, such as a button or a logo or an item icon or even a bit of text, has been found. And this testing from the user perspective is extremely important, even more so though in point of sale. Eggplant's able to validate the color, the font, the size, the layering, and positioning of any UI element on the point of sale screen. Eggplant's also able to report back on the performance as the end user experiences it. That is, Eggplant can tell us exactly how long it took for an UI element to appear on the screen, and this enables us to include performance timings in the test results and even fail or pass tests based upon those very timings. So the tests that are running now, they're representative of a lot of the asks that we see coming in from our point of sale customers. And one of the main asks is really about permutations on this core test flow at the register. So you can think of any kind of a normal point of sale environment where we have a customer and a cashier and a system like this point of sale terminal on the screen right now. Usually what regression sets have in them, traditionally, is several different types of transactions. Maybe we have a transaction with one item, with more than one item, with different quantities of different items, items that are added to the cart in different orders. Perhaps some items are removed from the order. Some of the items that are worked with might have restrictions, such as an age restriction. We might even be working in a particular store or tax context for this particular run. All of that information is exactly the kind of information that's actually already built into these tests and built into this automation because of the model and the way that that model is created. The other piece of this is the test data behind the scenes. So we might want some test data behind this model which tells us exactly which item to pick from the menu, and that's how this test is being driven currently. You can see in the model we only have single actions for select drink or select food. Behind the model there's also data that we can push into the test, and that data then is used with this generic action of selecting a drink or selecting a food. So we say, hey Eggplant, when you go to the food menu, like we are at now, go look for an ice pop lemon or go look for vanilla ice cream. I'm going to move over to the run report now, which I'm just showing, and talk about the run report, directed tests, and the coverage report. So the run report tab in Eggplant AI displays the details of the runs from your model. And by default, we see the runs from the current model that we're working with, which is our point of sale model. And I can click on any particular run and then expose the very granular details about what happened in that run, and all of that information is available down here in the console. Test cases are exposing directed tests. Remember, those are the tests that users define by clicking through the model and emphasizing a particular flow. The coverage report is the last thing I'll cover off here. And in Eggplant AI, the coverage report shows you how much of your model has been visited during particular test runs. So Eggplant reports on several different types of coverage. What we'll do is we'll change this to extended coverage, where we report on all the possible flows through the model that contain 3 consecutive actions or states. So here we can see all of those different 3 consecutive actions that are possible. There's one food menu dashboard order that's been accomplished, and one food dashboard food that hasn't been accomplished. So we can actually see with this coverage type the different strings of actions, those 3 consecutive actions or states. Some of them have been accomplished, some of them have not been, and this is that third order, that extended coverage that we see. That's about all we have time for the demo today, so we'll stop things here. I'll go ahead and kick some more tests off with this. We can leave this screen up so that you can get a further sense of how Eggplant's working. So I'll pass it back over to you. Thanks so much.
Thank you so much for that demonstration, Nick. I think that was really insightful for our audience. And thank you to everyone who joined us here today. If you have any questions, please don't hesitate to reach out to us at eggplant.io. We look forward to seeing you at the next retail event.